So in this video, we're going to go ahead and walk through these different circuit problems, circuit problem 1, circuit problem 2, and circuit problem 2.5. I know you're wondering, 2.5? There's a story behind that, I bet. But anyway, here we go. Starting with circuit problem 1. So what I want to do is, again, I am a huge fan of color coding. I think it really helps see what's going on in circuits. So I'm going to very quickly run through this one. Let's go ahead and make the highest V location on the circuit. We're going to go ahead and make that purple. So here's the high V side of this battery. We're at the long line side. All of this metal is connected. So this is all at the highest V level. And then let's see here, as I go through, we'll start dropping down V. As I go through this resistor, I'm going to dump off some energy, and my charge will have less energy per charge, my hypothetical positives flowing through. And then they'll hit another resistor, they'll drop off some more energy. And so they'll be at a lower V level here, going through here. Then hit another resistor, drop off some more energy, and they'll end up at this lowest V level for the circuit. Here, that is connected to the low V side of the battery, the short line end. And so that's it. That's my delta V's. I know my current is going to flow the way my hypothetical positives go out of the high V side of the battery, right? So here's my current flowing out to the whole circuit, right? And run through those three resistors. I notice that my current, as it flows, it has no choice of path. It goes through one, and then the next, and then the next. And so that means these three resistors are in series. And when you add up to find total resistance in series, you just take the sum. And so you say, hey, the total resistance is going to be 6 plus 10 plus 15. And you say that's going to be 31 ohms. Just adding up those resistors in series. And so then you say, what about the total current? Well, they tell me here V total is 155 volts. What they mean is that's the delta V for running through all the resistors. That's the delta V for the battery, essentially. Here, if I were to go ahead and mark that here, you'd say, hey, my delta V from one side of the battery to the other, it's a 155 volt battery if I hooked up my voltmeter. And so knowing that I go up 155 volts to the battery, I'm going to go down 155 volts going through the rest of the circuit because my total delta V for a complete loop has got to be 0. I go up the battery, down through the resistors. I can say, just look at the resistors, delta V is IR. And so 155 is my current through the resistance for the whole circuit. 31 gives me the current through the whole circuit. 155 divided by 31 would be 5 amps. And so my current is 5 amps. So 5 amps is what is flowing out of the battery to the circuit. Now, because it's series, that means 5 amps comes in the left side, 5 amps goes to the right side. You've got 5 amps flowing through this guy, 5 amps flowing through this guy, 5 amps flowing through this guy. There's nowhere else for that current to go. All those charges going through one are going to go through the next. So 5 amps, 5 amps, 5 amps. I'm really not a huge fan of filling in all these little blanks. Again, I like to see the data right there on the sketch where I need it. Now we'd like to know with resistances. You say the resistance between A and B. That's just the 6 ohm of that resistor. I mean, that's 6 ohms. And between B and C, you say that's just a 10 ohm resistor. And between C and D, that's just a 15 ohm resistor. And so now I can go ahead and calculate my delta V's. And you say, hey, we want to know the delta V from A to B. You say, well, from A to B, that's just the delta V on either side of this first resistor. That's just the delta V from purple to blue, right? You say, so I'm going to use Ohm's law. And I'm going to say, for that, I'll just do my delta V as IR. Now I'm doing it just for that part of the circuit, just from A to B. So my delta V from A to B is the current that flows through there. That's 5 amps times the resistance just between A and B, which is 6 ohms. That's going to be 30 volts. So this is 30 volts here. That's the delta V from purple to blue. Now we're going to go ahead and find the delta V from B to C. That's my delta V on either side of this resistor. And so you say, well, that's going to be, again, I'll do a little delta V as IR, just looking at that small region of the graph, of the diagram. And so you say, hey, that's going to be my current of 5 amps flowing through resistance of 10 ohms. That's going to be 50 volts. So 50 volts is my delta V here. And then my delta V from yellow to red, you say if I hooked up a voltmeter here, from anywhere here in yellow to anywhere here in red, you say I've got a current of 5 amps flowing through a resistance of 15 ohms, and 5 times 15 that's going to be 75 volts. And so this is 75 volts here on the sketch, and 75 volts here. And we can double check. You say, hey, I know going around in a circle, I got to add up to 0, right? I go up 155. These 3 voltage drops, I better add up to 155. So here we go. 75 plus 50 is 125. 125 plus 75. Did I just do that right? What am I saying? That's 30 volts. I'm sorry. 30 plus 50 is 80. 80 and 75 is 155 volts. And you say, that is exactly what we should have gotten. That matches the voltage of the battery. Ta-da! So that's a nice little circuit problem in series. Let's get circuit problem 2, which is slightly more interesting. You say, if I go ahead and I start my little color coding process, because I'm a huge fan. You say, I'm going to mark my high V side of my battery here in purple. I go along here until I hit a battery or a charge capacitor or resistor. You say, this resistor is going to take energy out, so I'll have an energy drop. Now I go through this region until I hit a resistor. It takes more energy out, so I'm going to have a new energy level. You say, look, all of this metal is all connected here until I hit a resistor, and that's all 1 V level. I go through this, I'm going to lose some energy per charge. I'll hit another V level here. All this is connected. And then I hit this one, and I have that last voltage drop. And so I'll have, this is hooked up to the low V end of my battery. And so I have this little lower V level here. So that's it. So I recognize that my current is going to flow out of my battery here, and it's going to go through this guy, then through this guy, and then when it gets to here, it's going to split at that junction. So it has a choice of path to get from C to F, if you would. It could go through this left branch through the 10 ohm resistor or the right branch, the 15 ohm. So these two are in parallel with each other, and then it flows to the next. So what I have here is I have series 2 in series with 4 in series with the combination of 10 and 15, and then in series with 8. So what I recommend, I'm a big fan of finding all my total resistances. So let's go ahead and crank that out first. And where I'm going to start, I'm going to start with this parallel combination here, right? These two in parallel, the 10 and the 15 is where I'm going to start. So you say, well, 10 and 15, they're in parallel. That's what the choice is. To get from C to F, the choice is through 10 or through 15. So I'm going to say 1 over our parallel is going to be 1 over 10 plus 1 over 15. You say common denominator, there's going to be 30ths. So I'll multiply this one by 3 over 3 and this one by 2 over 2. And so if I do that, this will be 3 30ths plus 2 30ths will be 5 30ths. But again, that's not my answer. I got to take the reciprocal, right, of both sides. 1 over RP is 5 over 30. Flipping it, you say, hey, that R parallel would be 30 over 5. That is 6 ohms. And so the resistance for that, the resistance for just this region here is 6 ohms. That's the resistance between C and F for this part. So I put it on the diagram right there where I need it and circle it so it's there when I need it later. Can we go ahead and find that total resistance of the whole circuit now? You say, sure. My current flows through. It goes through 2, 4, 6, 8. Who do we appreciate? You say that's 20 ohms. So 20 ohms is the resistance for that whole circuit. Now I want to go ahead and find the delta V for the whole circuit, okay, for all these resistors. And so you say, well, I'm just going to go ahead and use Ohm's law for that. And so you say Ohm's law, I'm going to do a little delta V as IR. And you say, well, the delta V for the whole circuit, that's going to be the current through the whole circuit, which they tell me here is 4 amps, is what's flowing out of the battery, is what this is trying to tell me, that flows through the whole circuit. Times the resistance for the whole circuit, I just calculated that to be 20. That would be 80 volts. That is the total voltage drop for those resistors. That means that must be the voltage rise going through the battery here had better be 80 volts. So I go up 80 volts here, and I go down 80 volts as I go through the rest of the circuit. So now that we know this, right, and they told us this was 4 amps flowing out of the battery, I know that the current that flows through AB here, that's just 4 amps continues on through this, right? There's no choice of path. That's 4 amps. and then it flows then into what goes out of the 2 ohm resistor, goes into the 4 ohm resistor. That's 4 amps through that guy. That's from B to C. You know what? I'm just going to fill in these silly little blanks later. Like I said, I'm just going to put all my information in the diagram. I'm going to solve for everything for the circuit. When I get to this junction, it's going to split. And so some of that 4 amps will go this way, and some of that 4 amps will go this way. Figuring out how much current goes through that little branch is kind of a tricky little thing until you've found that total resistance for that region. We'll come back to that. At this junction down here, I know that the current in the 2 branches are going to join back up again, and I will have 4 amps flowing out of that region, right? What flows into the region, 4 amps, it better flow out of the region because you can't create a destroy charge. 4 amps then goes through this guy, and then it goes back to the battery. All right, so there are 4 coulombs every second flowing out of the battery to the circuit and then flowing back in. Okay, got it. So what are we doing now? Like I said, we've got all of our currents everywhere except for these 2 little branches. Well, the trick is, if I want to use Ohm's law, delta V is IR, you have to know 2 of the variables to find the third. And right now, for this little branch, all I know is the resistance for this branch is 10 ohms, but I don't know the delta V, so I can't find the I yet. So I actually first have to find the voltage. And the way I do that, and this is like the trick, is don't worry about the little branch. Just use the whole region, this whole right end of the circuit. I'm going to treat it like it's just a 6 ohm capacitor. Did I say capacitor? 6 ohm resistor that has how much current going through it? 4 amps flows through the whole region. Make sense? That is the trick. Otherwise, you get kind of stalled out when you can't find something in a little branch. You got to back up a step, look at the whole region. So I'm going to do delta V is IR for that whole region. I know the current through the whole region is 4 amps, and the resistance for that region I solved was 6 ohms, so that's going to be 24 volts. That is my delta V for this whole region. So that's anywhere in green to anywhere in yellow, right? I just figured out that was 24 volts, right? If I hooked up my voltmeter. So now that I know the delta V for that region, you say, wait a minute, anywhere in green to anywhere in yellow is 24. I can use that value I just calculated for just this one branch, right? Because anywhere in green, anywhere in yellow, that's 24 volts. So that's the trick. So you say, okay, 24 volts there. Now I know 2 things here. I know the delta V for this branch, and I know the R for the branch, because the delta V for the branch is the same as the delta V for the whole parallel part. So just looking at this branch now, the left branch, I can do a delta V is IR. I can say I'm going down 24 volts. That will be equal to the current in that branch times the resistance of that branch, 10 ohms. So that'll be 24 divided by 10 will be 2.4 amps is my current in that left branch. So I just figured out, hey, this right here, that's 2.4 amps. I can do the same trick on this other branch. You can say I can do a delta V is IR for just that right branch. And I can say the delta V, again, we know has to be the same as the delta V anywhere in green to anywhere in yellow, came out to be 24 volts. Be the current in the right branch times the resistance in the right branch. And you say 24 divided by 15. So 3 goes into that, 8 times 3 goes into that 5 times, so it's 8/5, or if you like 16/10, that would be 1.6 amps is the current in the right branch. And that should jive with what we know here. We can double check that using Kirchhoff's junction law, right? You can say, hey, if I have 4 amps flowing in, right? 4 amps, and then it splits up here, and 2.4 amps go this way, I better have 1.6. 2.4 plus 1.6 adds up to be the 4 amps that went in. So that jives. Hey, did we just find everything for the circuit? Nope, we're missing one more thing to calculate. One last thing over here. You say, hey, we really ought to find the delta V for this last resistor, right? Say, what's the delta V here, right? And so if I do my calculation for that last resistor, I say delta V is IR. The current going through that resistor is 4 amps, and the resistance of that resistor is 8 ohms, and 4 times 8 is 32 volts. And so that would be 32 volts is what I would read off on my voltmeter connecting from there to there, right? We can double check this, right? We know that I can just add up all my delta V. So from here to here, you say, what's the delta V there? Oh, I didn't calculate that one either. Delta V is IR. Right, so it's going to be 4 amps through 2 ohms is 8 volts. All right, there we go. So, same thing here. Whoops. Delta V 4 amps through 4 ohms is 16 volts. Okay, there we go. So running through, watch. We go down 8 volts from purple to blue, and then we go down 16 volts from blue to green, and then we go down 24 volts from green to yellow, and we go down 32 volts from yellow to red. And if I add up 8 plus 16, that's 24. Another 24, that's 48. 48 and 32 gives you 80 volts, which is the voltage of the battery, and that makes sense. And that's it. Should I fill in all these silly little blanks now? No. Let's move on with our lives. Like I said, I like putting the data right on the diagram. It's there where I need it, right? Fill in the little blanks there. Here we go. Last circuit problem 2.5. So in this one, it looks like they don't tell us the voltage of the battery. They tell us all the resistors. And the other information they give us this time is they tell us here that the total current is 5 amps. Okay, so I can go ahead and I can mark that and say, look, I've got 5 amps of current flowing out of the battery to the circuit is what they're trying to tell us. You say that's, so I've got enough information here I can start working from. I've got 2 pieces of delta V as IR. I've got the current going out, and from all the resistors, I can calculate the total resistance. That will give me the total voltage for the circuit. So that is what we're going to do. So we're going to find the total resistance is going to be the next thing I'm going to calculate for. So you're like, dang, calculating total resistance. This is a somewhat more complicated circuit, right? So where do you start? I like to start with the tiniest little fiddliest innermost little bit parallel branches. So let's start with this upper part here. I'm going to find this region. I guess we could call this B to F here, right? Okay, so in between B and F, what's the resistance of this top little triple branch thing? And so you say they're in parallel, right? Should I color code all my delta V's? Is it ahead of time to do that? I don't know. Sometimes it helps. So you say, here, here's my high V side of my battery. Here's all V until I hit the resistor. Now I'm going to drop off energy, so I'm going to have different energy per charge, so different V level there. Let's go ahead and tag that one in pale blue. Hey, this is all linked up here. It's all connected. It's all one V level there. I'm going to go through resistors, lose some energy. On the other side, say, hey, look, this is all connected in here, right? All this is all one piece of metal, essentially, right? All connected until I hit something's going to take energy out here. I'm going to go down again. You say, okay, all this is all connected one V level. I'm going to go down voltage again. And so this is all one V level going up over to here, right? Yeah. Okay, until I hit resistors. I'm going to drop off energy again. Got another V level. Uh-oh. Dang. I'm running out of colors. Okay, this one's going to be pink. There we go. Until I hit this last resistor, right? I'm going to go down V level one last time. And going to get the V level of the low V side here in red. So there we go. So there's our all of our voltage, different voltage regions labeled for us, which I find to be helpful sometimes in thinking about what's happening in the circuit. So let's go ahead and find our equivalent resistances here. You say, here I've got this triple. You say to get from blue to green, I have my choice of 3 paths, right? And so those 3 paths are in parallel. So I'll use the parallel formula. I add up the inverses of the resistances of all the branches. That gives me the inverse of the total. And so you say, I'm going to have a 1 over 5 plus a 1 over 10 plus a 1 over 10. And so get a common denominator is going to multiply this one by 2 over 2. So I have 2 tenths and 1 tenth and 1 tenth. That will be 4 tenths. But that's not the answer. You got to revert. We got to flip it. So our parallel is 10/4, which you say that is 2.5 ohms. Do you like 2.5? Do you like 5 halves? What do you prefer? I don't know. I'm going to write it as 5 halves. I'm going to write it as look at this. I'm going to write it as a fraction. Everybody loves fractions. Here we go. 5 halves ohms. I'm going to circle that. I'm going to remember that is for this whole region is 5 halves ohms. Okay, let's also find this branch here. Look, I've got to get from orange to pink, I have my choice of going through the 10 ohm or the 30 ohm. So again, that's in parallel. So I can say 1 over R parallel, that's going to be 1 over 10 plus 1 over 30. Get common denominator, going to multiply this by 3 over 3. So it'll be 3/30 plus 1/30, that's 4/30, but that's 1 over. So my R parallel is going to be 30 over 4. You say 30 over 4, that is 7.5 or 7.5 ohms. I don't know why. I'm going to write that as 15 halves. I don't know. I'm feeling like fractions today. What can I say? 15 halves ohms. So that's it. So now what's my resistance? Well, now my current comes through. It goes through the 4, then it goes through the 5 halves, then it goes through the 5 ohms, then through the 8 ohms, then through the 15 halves, then through the 7 ohms. So that's series, right? This guy, then this region, then this guy, this combination, right? And then this, and then this, and this combination, and then this. All right. So adding up in my head, order we add doesn't matter. Hey, you know what 5 halves and 15 halves is? That's 20 halves. That's just 10, right? So these two parts just have to be 10 ohms plus the 4 ohms plus the 5 ohms. That's 19 plus the 8. That's 27 plus the 7. That's 34 ohms for my total resistance for the circuit. So let's see, my total resistance comes out to be 34 ohms. Now I know they told me the total current going out to the circuit is 5 amps. 5 amps going through 34 ohms. We can do a delta V is IR for the whole circuit. And I can say, hey, the delta V for the whole circuit is going to be 5 amps through 34 ohms. And you say, hey, that's going to be, 5 times 34 is 150 plus 20. That's 170 volts. And so that is the delta V for the battery. And that's that total voltage drop going through the circuit, right? So if I were to hook up a little voltmeter here and I were to connect, right, that would read 170 volts. All right. We know that all these silly little blanks are going to be just finding delta V's for every little resistor and the currents every little bit and da-da-da-da-da. Let's just run through and mark it all on the diagram and worry about the little blanks later. Okay, so let's go to calculating delta V's, okay, is what I'll go ahead and do next. So delta V, let's find delta V here for this resistor. Hey, look, I've got 5 amps through 4 ohms. This is just going to be do a delta V as IR. And so it's just going to be the current times the resistance. 5 through 4 is going to be 20 volts. Okay, this whole region, remember that's the trick. The whole region I'm going to treat like it's 5 halves, and I've got a current flowing through this whole region of 5 amps, right? Now it splits up into little bits and little branches, but as a whole, this acts like one big 5 halves ohm resistor that has 5 amps going through it. So if I hook up from one side anywhere in blue to anywhere in green, it's going to be 5 amps times 5 halves ohms, which is 25 halves or 12.5. I said I was going to do fractions, but look at me changing to decimals. 12.5 volts. Okay, and then same thing here, going through green, right? The current, I had 5 amps flowing in, right? But then that current, that 5 amps going in, it split up. But coming on the other side here, that current, it all joins back up again, right? And so I'm going to have 5 amps flowing again, right? And so 5 amps through 5 ohms, that's going to give me a delta V here of 25 volts. And then 5 amps through 8 ohms gives me a delta V here of 40 volts. And then anywhere in orange to anywhere in pink, right? I'm going to have 5 amps. Yeah, the 5 amps splits up, but that's okay. I'm going to have some going this way and some going this way. But I'm just interested in finding a delta V for this whole region. So I'm going to use the resistance for the whole region, 15 halves, times the current through the whole region, 5 amps. 5 times 15 halves, 75 halves. That would be 37.5. That's 37.5 volts, right? And again, those two currents that split, they join back up again on the other side, right? And so once again, we'll have 5 amps flowing. And here's 5 amps flowing through 7 ohms. And so if I did my delta V, 5 amps through 7 ohms, that's going to be 35 volts. And so if I double checked all my voltages, right? You say, if I make a complete loop, end up back where I started, the total delta V better be 0. You say, I'm going up 170 here, and then I'm going to go down, 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 going through the rest of the circuit. So The rest of the circuit here better add up to be 170 volts voltage drop. So you say, here we go, 20 from purple to blue, plus 12 and a half, right? Going, oh, that's really sloppy. 12 and a half going from blue to green, and then 25 going from green to yellow, and then going down 40 volts from yellow to orange, going down 15 halves, that's 7.5, going from orange to pink, and then going down 35 volts, going from pink to red. And if we add those up, let's see here, half and a half is going to give me 1, right? Okay, and so 1, 2, 3, 8, 15, 20, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That gives me 140 volts. And you say, that's not what I was supposed to get. Did I miscount somewhere? Yeah, I did. See this? Look at this. Look at this. I put 7.5. That's the resistance there. It's not the volts. The voltage there's 37.5. Dave, come on. Okay, half and a half is 1. 1, 2, 3, 8, 15, 20. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, 170. That is what we were supposed to get. Yes, 170 volts. That is my total delta V there, and that's right. So it matches up. Hey, what's left to solve for? You say, holy cow, we just solved for all the voltages everywhere. The only thing left to solve for is to find the individual little currents in the little branches of the different parallel parts. So we can find these currents using, again, Ohm's law. Once again, delta V is IR. How many times have we used Ohm's law in this problem, right? You use it over and over again for like the whole circuit, for regions, for individual little resistors. Finding these currents, let's go ahead and use this branch. It's got a 10 ohm resistor. This 10 ohms ought to be a little lower. Sorry about that. You say, just using this little branch, can I do a little delta V as IR on just that little branch? You say, sure. I know delta V anywhere in blue to anywhere in green, that is 12.5. I know the current through that branch times the resistance of the branch. What's the resistance of the branch is just 10. And so rearranging this, that means 1.25 amps. 1.25 is the current through that bottom branch. 1.25 amps. Right? And you say, hey, this branch, it also is a 10 ohm with delta V of 12.5. So this one will also be 1.25 amps. And you say, well, wait a minute, 5 amps flowed in. You say, if I went and do delta V as IR, no, we can just use the junction law, right? 5 in, 1.25, 1.25, that would be 2.5. I must do got to be 2.5 going through here. If you stop and you think about it, look, it's the same delta V. This branch has half the resistance, so it will have twice the current of the other branch. See? 2.5 versus 1.25. Okay, and they add up to be the 5 amps with the junction law. I could do a delta V as IR for the top branch if I wanted. It would be real quick. You'd say, hey, I do delta V as IR. And you say, hey, that top branch, delta V is 12.5. It's going to be my current times the resistance of just 5. And you say 12.5 divided by 5, that would be 2.5. So that makes sense. Okay, let's do something similar down here for this bottom 2 resistors in parallel. I'll do a little delta V as IR. I guess I'm going to squeeze it in here. And you see my delta V here going from orange to pink. I am going down 37.5 volts. That's going to be my current. Let's do the top branch. 10s are easy to work with, right? It's going to be I times 10. And so you say, rearranging, that means my current through the top branch is going to be 3.75 amps is the current in the top branch. 3.75 amps goes this way. And so using the junction law, you say, gosh, 5 amps goes in, 3.75 goes up. I better have 1.25 amps. Wow, that's really sloppy. 1.25 amps going the other way. And sure enough, so that junction law works. So what flowed into that junction there equals what flowed out of the junction. We can double check that if we want with Ohm's law. Do a little delta V as IR. and say the delta V is 37.5 volts for that bottom branch, anywhere from orange to anywhere in pink. And the current through the bottom branch times a resistance of 30. And so if I did 37.5 divided by 30, you say, this is where I normally would just pull out my calculator. Well, though I know that 7.5 times 4 is 30, right? So actually, that is 5/4, right? And you say, hey, you know what 5/4 is? You say, gosh, that's 1.25 amps, and that is what we got. So that's it. So that's all solved out, that circuit. We solved for every delta V everywhere, every voltage, right? Every resistance. The only other questions we could be asked, someone could ask us about power ratings for things. And that's easy to do. Just use our power formula, current times voltage, for whatever little chunk they're interested in. And that's it. That's those 3 circuit problems solved. Hope this made sense and that you get the hang of it, right? You really have to work through some circuit problems on your own to get the hang of this trick of how you treat it. Oh, I'm going to use Ohm's law for just from here to here, and I'm going to use it from here to here, and following your way through the circuit. If you are really, really interested and you'd like to have even more circuit problems to practice with, I have more sicker ones and some easier ones too, if you're interested. All right, that'll do it for this video. Next video, we'll be explaining using Kirchhoff's laws to solve circuits with multiple batteries. Okay, and we're also going to use Kirchhoff's laws for RC circuit problems. That's problems with resistors and capacitors in a circuit. And that's the last topic, is RC circuits. So that's next video. We're going to be taking a look at using Kirchhoff's laws